What are electromagnetic waves? Electromagnetic waves are a form of energy that consists of oscillating electric and magnetic fields. How do electromagnetic waves propagate? They propagate through space as transverse waves, meaning the electric and magnetic fields oscillate perpendicular to the direction of travel. What is the speed of electromagnetic waves in a vacuum? In a vacuum, electromagnetic waves travel at the speed of light, denoted by c, which is approximately 3 × 10⁸ meters per second. How are the electric and magnetic fields related in an electromagnetic wave? The electric and magnetic fields are perpendicular to each other and to the direction of propagation, with the electric field oscillating in one plane and the magnetic field oscillating in a plane perpendicular to it. What is the relationship between the frequency and wavelength of an electromagnetic wave? The frequency f and wavelength lambda of an electromagnetic wave are inversely proportional, given by the equation c equals f times lambda. What is the electromagnetic spectrum? The electromagnetic spectrum is the range of all possible frequencies of electromagnetic radiation, including radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. How are electromagnetic waves classified based on their frequencies? Electromagnetic waves are classified into different types based on their frequencies, with radio waves having the lowest frequencies and gamma rays having the highest frequencies. How do electromagnetic waves transfer energy? Electromagnetic waves transfer energy through the oscillation of electric and magnetic fields as they propagate through space. What is the relationship between the electric and magnetic field strengths in an electromagnetic wave? In an EM wave, the electric field and magnetic field carry the same energy. So in an EM wave, the magnitude of the electric field is proportional to the magnitude of the magnetic field, and the proportionality constant is c, the speed of light. What is the role of Maxwell's equations in describing electromagnetic waves? Maxwell's equations are a set of fundamental equations in electromagnetism that describe how electric and magnetic fields interact and propagate, providing the theoretical framework for understanding electromagnetic waves. How do electromagnetic waves interact with matter? Electromagnetic waves can be absorbed, transmitted, or reflected by matter, depending on the properties of the material and the frequency of the waves. What are some common sources of electromagnetic waves? Common sources of electromagnetic waves include the sun, stars, artificial light sources, radio and TV transmitters, microwave ovens, and X-ray machines. What are the properties of radio waves? Radio waves have long wavelengths and low frequencies, making them suitable for communication and broadcasting over long distances. How are electromagnetic waves used in communication? Electromagnetic waves are used in communication systems such as radio, television, cell phones, and Wi-Fi, where information is encoded onto the waves and transmitted through space to a receiver. What are the applications of microwaves? Microwaves are used in microwave ovens for heating food, in radar systems for navigation and weather forecasting, and in telecommunications for long-distance communication. What is the relationship between the energy and frequency of electromagnetic waves? The energy of an electromagnetic wave is directly proportional to its frequency, as described by Planck's equation, E equals hf, where E is the energy, h is Planck's constant, and f is the frequency. How do infrared waves affect temperature? Infrared waves are absorbed by objects and converted into heat, leading to an increase in temperature. What are the uses of infrared waves? Infrared waves are used in thermal imaging cameras, night vision goggles, remote controls, and heat lamps. What is the visible light spectrum? The visible light spectrum is the portion of the electromagnetic spectrum that is visible to the human eye, ranging from approximately 400 to 700 nanometers in wavelength. How does the color of light relate to its wavelength? Different colors of light correspond to different wavelengths within the visible spectrum, with shorter wavelengths appearing as blue or violet light and longer wavelengths appearing as red or orange light. What are ultraviolet waves? Ultraviolet waves have shorter wavelengths and higher frequencies than visible light, and they are invisible to the human eye. They are commonly associated with sunlight and are responsible for causing sunburn and skin damage. What are the effects of ultraviolet waves on living organisms? Ultraviolet waves can cause skin damage, sunburn, and increase the risk of skin cancer in humans. They also play a role in the production of vitamin D in the skin. How are X-rays used in medicine? X-rays are used in medical imaging techniques such as X-ray radiography, computed tomography (CT) scans, and fluoroscopy to visualize the internal structures of the body and diagnose medical conditions. What are gamma rays? Gamma rays are the highest energy electromagnetic waves, with the shortest wavelengths and highest frequencies. They are produced by radioactive decay and nuclear reactions. How are gamma rays used in medicine and industry? Gamma rays are used in medical treatments such as radiation therapy for cancer and sterilization of medical equipment. In industry, they are used for inspection, testing, and sterilization processes. How do electric and magnetic fields interact to produce electromagnetic waves? When an electric charge accelerates or changes direction, it creates a changing electric field, which in turn produces a changing magnetic field. These changing fields propagate through space as electromagnetic waves. What is polarization in electromagnetic waves? Polarization refers to the orientation of the electric field vector in an electromagnetic wave. Linear polarization occurs when the electric field oscillates in a single plane, while circular and elliptical polarization involve complex patterns of oscillation. How do antennas generate and receive electromagnetic waves? Antennas generate electromagnetic waves by oscillating electric currents, which produce changing electric and magnetic fields. They also receive incoming waves and convert them back into electrical signals. What is the role of the magnetic field in electromagnetic waves? The changing magnetic field in an electromagnetic wave induces an electric field according to Faraday's law of electromagnetic induction, completing the cycle of mutual induction between electric and magnetic fields. How do electromagnetic waves transfer energy and information over long distances? Electromagnetic waves travel through space, carrying energy and information encoded in their oscillating electric and magnetic fields. They can propagate over vast distances without the need for a physical medium, making them ideal for long-distance communication and exploration.